Hello everyone, welcome back to this video series on clinical SAS ADaM programming. In this video, we will see how to create a questionnaire-based analysis dataset. The specific questionnaire that we are looking at is EQ5D. So again, the data that we will be using in this example is from a parallel arm study. So let us move to the lesson description to see what will be covered in this lesson. So here in this we will see creation of EQ5D-5L analysis dataset. It includes derivation of param CD, param N, param, parcat1, parcat1 and derivation. It also includes creation of a derived parameter which is moderately complex. The derived parameter is that composite health index. So we will be using the information collected in our questionnaire dataset. So we will create parameters for individual collected tests, and we'll also create a derived parameter which is called composite health index. And then in this lesson also involves creation of baseline flagging and creation of dependent variables like ABLFL, base, base C, and change from baseline. It also includes creation of an analysis flag called ANL01, which is used to select one record per analysis visit per parameter and per subject. And it also includes creation of an analysis flag called ANL02FL. This is used to identify the post-baseline records. So here is a quick introduction of what is EQ5D and what does 5L mean. So EQ5D is a questionnaire that is used to evaluate the quality of life of the clinical trial participants. So it is a descriptive system that comprises 5 dimensions, which means the quality of life of the participant is evaluated in terms of 5 dimensions, which is mobility, self-care, usual activities, pain or discomfort, anxiety or depression. So question will be asked on each of these 5 categories, and they will be asked to rate the 5D stands for these 5 dimensions, and 5L stands for the levels of response which they will be able to get to select. So each dimension has 5 levels. So if you see here, mobility would be checked in terms of no problems at all, slight problems, moderate problems, severe problems, or extreme problems. So each of the question would be rated on these 5 levels. So that's why we call it as 5 levels, and the 5 dimensions are listed here. So, and the patient is asked to indicate his or her health state by ticking the box next to the most appropriate statement in each of the 5 dimensions. So, which becomes our raw data, and that we would translate into our SDTM questionnaires dataset when we are programming SDTM datasets. And then this decision for each of the questions, we would end up having a 1-digit number that expresses the level selected for that dimension. And the digits of the 5 dimensions can be combined into a 5-digit number that describes the patient's health state overall. So this is some background about the questionnaire that we are looking at, which is EQ5D-5L. Now let's move to the programming specification for this. So here we have been given with the variable name, variable label, and the derivation algorithm. So if the convention is like the SDTM dataset name and the followed by the variable name, so it means that the variable is supposed to be a direct copy from the relevant SDTM domain. So here in this case it is QS. So, and if the convention is like ADSL.subjd, which means that this variable has to be pulled as a direct copy from ADSL dataset into our ADQS dataset. So we have some variables which are direct copies from SDTM QS dataset and some variables which are direct copies from ADSL dataset. And then here is our first derived variable, which is ADT. So it says populate using QSDTC. So ADT is supposed to be a numeric variable as per ADaM standards. So QSDTC is a character date type in SDTM QS. So we will be using QSDTC and converting it into numeric format. And then we have our ADY variable, which is analysis relative day. So the derivation says populate using ADSL TRT SDT and ADQS ADT, so which we would have derived in the previous step. So if ADT is on or after the treatment start date, then populate as the difference between ADT and TRT SDT and add 1 to the difference, so which would get translated as ADT minus TRT SDT plus 1. Else if ADT is before TRT SDT, then populate as the difference between ADT and TRT SDT. So which means it will be ADT minus TRT SDT only. And then epoch, so we are just getting it carried forward from SDTM QS domain. Similarly is the case for visit num and visit. And then we have a visit here. So for we have two components involved here. The first one says populate with qs.visit for scheduled visits and leave null for unscheduled visits. So only on the scheduled records, scheduled visit records, we are populating the value directly from qs visit variable. And the second component is populate as baseline on baseline records. So which could be identified using the condition where ADQS.ABLFL is equal to y. So on all the records where ABLFL is equal to y, we will have to populate the a visit value as baseline. So then we have our a visit and variable. It says populate with qs.visitNum for scheduled visits, similar to what we have done for a visit, and then leave null for unscheduled visits. And the second component says populate as 0 on baseline records. So which means on the records where ABLFL is equal to y, we will have to populate the a visit and value as 0. So note that there are two components involved, so we cannot complete the derivation of a visit unless we have the ABLFL is equal to ABLFL flag derived. And then we have parameter definition. It says for the source records, when set to mobility, when QS test is equal to mobility, and then when it is self-care, so we are populating it as self-care in only the first letter is uppercase and the remaining letters are in lowercase. Similarly for usual activities, pain or discomfort, anxiety or depression, and your health today. So all of these QS test CD values, QS test values are being translated into some value in param variable. And there is a component B involved, so it says create a new derived parameter called composite health index using individual scores. So there are some parameters which are getting created from the source tests which are present in SDTM, and we are creating a new derived parameter which is not present in SDTM but purely has to be created in ADaM ADQS. And then for param CD, we are being asked to set to QS test CD for the source records, and for the newly derived parameter composite health index, so we are being asked to use the value of CHI in param CD variable. And then for param n, so for the source parameters, so we are asked to extract the last character from the param CD and convert it into numeric. So we'll see what the values are in param CD, in fact in QS test CD, and then we were asked to extract the last character from that value and convert it into numeric. We'll do that. And then for the derived parameter composite health index, so we are being asked to set it to 7. And then param type, so we are being asked to set it to derived on the newly created parameter, which is param CD is equal to CHI. And then QSCat, we are using it to create parcat1 variable. And then here for parcat1n, which will share a one-to-one relationship between parcat1 values, so we are being asked to set a value of 1 when QSCat is equal to EQ5D-5L. And then comes our eval definition. So it says for the source record, so we are being asked to use the value from QSSTRESN and then set to eval variable. And for derived parameter composite health index, so we are being given the algorithm. So if we see the algorithm is provided here, we'll go through that in a while. So here it involves multiple parts. So here if we see there is B1, step B1, step B2 and step B3. So we'll first see the step B1. So it says create a temporary variable named score by multiplying the factor provided based on the response for each parameter. So conversion factors for each response of a parameter are as shown below. So for the first parameter, if a subject has chosen a response which corresponds to the value of 1, so that is scored as 0. And if they have chosen the response which corresponds to 2 in eval variable, so it gets a score of 0.051. And similarly, so 0.063 for 3 and so on. So these are the scores or the rating that would be used for the response for all the records corresponding to parameter 1. And similarly, we have been given the scores for parameter 2. So if eval is equal to 1 here for parameter 2, that would get a score of 0. If for paramin is equal to 2, if the eval value is 2, so it gets a score of 0.057. So note that these are not same across different parameters. The scores are different for different parameters, so we'll have to create them separately. So for each response chosen by the user, for each of the parameters, they are being converted into another number. So that conversion factor, what we need to do is we will have to, if it is 2, for example, for parameter 2, so we need to use a value of 0.057. And then we have been given the scoring, the scores for each of the parameter for all 5 parameters. And then in the step B2, so we are being asked to transpose the score such that scores of all parameters are on a single record at a time point. So for a subject, they would have chosen a response which would be vary from 1 to 5, and for each of the parameter now we have given a score, and now we are being asked to fetch all the scores of all 5 parameters onto a single record at that time point. So for example, if the subject has taken this questionnaire, they would have answered these 5 questions with some numbers. And then we'll, as per the SDTM structure and ADaM structure, we would have all of these as rows. But in order to complete the derivation, so we are being asked to fetch it as columns so that we can do some manipulation. So transpose the score such that scores of all parameters are available on a single record at a time point. If they have attempted that questionnaire on 1st Jan 2010, so we need to have the scores of all 5 parameters as variables. So we will be transposing the scores to have that. And then when the score is available for all 5 parameters, so which means none of the 5 parameters should have any missing score. Only when all the scores are available for all 5 parameters, create eval as 1 minus 0.9675 multiplied by sum of the scores of all parameters 1 to 5. So if, say for example, if one of the subjects do not have or did not rate this, give a respond to this parameter 5, so this compound health index do not have a meaning, because we are explicitly told that the score, when the score is available for all 5 parameters, then only create the eval for composite health index. So we'll see how this can be programmatically implemented in a while. So, and for eval C, we are being asked to, for the source parameters, populate it with QSSTRESE. So, for the derived CHI parameter, as the result is expected to be only numeric, we do not need to populate eval C if we do not need it anywhere in further in the TFL analysis. And then we are being given the definition for base variable. So it says populate using ADQS.eval on the record where ADQS ABLFL is equal to Y for each parameter and subject on all records of that subject and parameter. So we'll have to use the value present on the record where ABLFL is equal to Y for that subject and parameter, and populate it across all records of that subject and parameter. And then base C shares similar definition to base, but only thing is that we need to use the value from eval C instead of eval. And then we have change from baseline. So it says populate as the difference between ADQS.eval and base on post baseline records. So the post baseline records could be identified from this flag ANL02FL. So we have not seen the definition for it yet. So it will be somewhere down the line here. So we will be able to identify the baseline, post baseline records using this flag, and then we'll have to calculate or change only on those records. And then we have been given the derivation for ABLFL. It says populate as Y on the latest record with non-missing result on or prior to the treatment start date for each subject and parameter. So it is on or prior to the treatment start date and the latest available if we have more than one record. And then we have one flag called ANL01FL, which says populate as Y on the latest record within each analysis visit per subject and parameter. So for example, at week 1 or so, if there are two records within there are two records with analysis visit is equal to week 1. So we are being asked to flag on only on one of the records, and that too on the latest record. So they will be deriving this flag. And then we have definition for ANL02FL, which says populate as Y on post baseline records. So it says post baseline records could be identified with the condition ADT greater than TRT-STT. So treatment start date. So ADT is the collection date. So all the collections which are made after treatment start date are considered as post baseline records. And then we have three more variables which are coming as direct copies from ADSL dataset. So which is SAFFL safety flag, and then randomization flag and enrolled flag. So now we will move to the programming aspect of this. So here on the left hand side of my screen, I have the SAS program that is used to create our ADQS EQ5D dataset. And on the right hand side, I have my input dataset and also all the intermediate datasets that are getting created and including the final dataset. So similar to my previous lesson, so all the data that is used for this lesson is stored in a SAS program, and I am including that program here. So what happens when I run this piece of code is that the entire SAS code present in that second SAS program gets executed in this SAS program, and all the datasets that are required for my lesson would be available for me in the work library for me to continue further with the programming for the task. So let's now move to the core step. So here I am sorting the as we were discussing, we are creating an analysis dataset which is based on a questionnaire. So the SDTM source dataset for questionnaires is QS domain. So we are using our QS dataset and sorting it based on study ID and subs ID. And then similarly, we are sorting our input ADSL dataset based on the same variables using proc sort. And then here we are merging our QS and ADSL dataset. At this time of ADSL merge, I'm only fetching study ID, U subs ID, and TRT SDT because I need TRT SDT to identify a few things like post baseline records in order to create study day, etc. So I am fetching TRT SDT and I am only using the records where result is present. If the test is not done in questionnaire, I am not using those records in the analysis. So I am filtering off those records using subsetting if statement. So the base data set for all downstream processing for me is my QS01 now. So let's take a quick look at QS. So we have the individual questions collected and the responses available, and the standard result numeric stat variable visit num visit date of collection epoch, all of the variables are available in my input data. And then here is my ADSL dataset. I have some important variable that would be needed for my ADQS derivation. And then I created my QS01. If I see to my existing QS dataset, I should have only TRT SDT added towards the end. So it is the case. So I have TRT SDT available in my QS01 now. And then now we'll move on to the creation of the variables which are directly based on input variables. So we have seen that in some of the cases there are some variables which are copies of the SDTM variables, and some can be used to create other variables. Like say for example, we can create ADT using QSDTC. So we will handle such kind of derivations in this initial step. So parameter related variables. So we have seen that for the source parameters which are present, so we were asked to use the values present in QS test CD for param CD. So we are now having only the source parameters. So we'll derive all the information required for source parameters first, and then we'll move on to the creation of the new derived parameter, which is composite health index CHI. So here we are handling the information for only source records which are directly coming from QS. So here we are assigning the values of QS test CD to param CD, and then here we are creating a param variable as per the specification. So we were given an algorithm like for mobility. So in QS test, the value seems to be in all uppercase. So we are being asked to populate it with only M capital and then all the letters in smaller case or lower case. So we are completing our param variable derivation using if then else statements here. And then for param, so we were asked to use the last number from our param CD and then convert it into numeric. So for param CD, it is equivalent to our QS test CD. So if you take a look at the QS test CD values here, so the last number is 1, 2, 3. The last character has a number like 1, 2, 3, 4, 5, and so on. So if we are being asked to extract that number and then convert it into numeric. So I am making use of substr function to extract the last character. So here if we see EQ5D-5L, so 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 characters in total. So what is the logic that I'm using here is, so from param cd, so when I say length of param cd, this would return me the value of 8. So the second argument for substr function, I am making use of length function. So as we had to extract the last letter, so that is in 8th position, so the last position. So I can get that position dynamically by using length function, because when I run the length function, it would return the value of 8. So what at the end what I wanted was the 8th position number. So I say for example it only had 7 characters, and if we had to extract 7, so what would happen? So when the length function would return 7, so that last character would be extracted when we specify the second argument for substr function using the length function. So I'm using that, and then I'm using input function to convert it into numeric value. And then for parcat1, so we were simply asked to populate with the value from qscat. So I am assigning that to parcat1 here. And then for parcat1n, so when it is EQ5D-5L, so we were asked to populate a value of 1. So we are doing that here. And then we are creating some timing variables here. So if length of QSDTC is greater than or is equal to 10, then we are extracting the date component, because as I discussed in some of my previous videos, when I say YYMMDD 10 dot, even if the date value has more than 10 characters, only the first 10 characters would be read here. So input of QSDTC and converting it into a numeric using input function using in format of YYMMDD 10 dot. So if n miss of ADT and TRT SDT is equal to 0, then do. So here we are creating our study day variable. So if ADT is less than TRT SDT, so we were asked to just fetch the difference between ADT and TRT SDT for ADY. So which is what we are doing here using a if then statement. And then else if ADT is greater than or is equal to treatment start date. So we were asked to fetch the difference between ADT and TRT SDT and then add 1 to the difference. So we are doing that here. So this completes our derivation for ADY as well. And then so we are handling the first part of our A visit and derivation. So using this do group processing here. So we were asked to populate A and A using A and A using visit num and visit respectively, but only on scheduled records. So here I am making use of find function to see if the variable visit has the text unscheduled in it. So because if it is present, that would be an unscheduled visit, and if it is absent, so I am checking for the absence by using a value of 0 on the find function returned value. So when it is 0, I am assigning the value of visit num variable to a visit and visit variable value to a visit variable. So this is kind of, we have out of the two components of a visit and a visit derivation, we have handled the first part here, and we will complete the rest of the thing in the subsequent derivation after we derive ABLFLY, because the second component involved the usage of ABLFL for both a visit and a visit variables. And then I'm writing a format for ADT to display it in date9 format. And then we are creating some other variables. So for eval, so as this is for source parameters, so all we need to do is assign the value from QSSTRES into this variable. And then here we are creating a evalc variable. For evalc, as these are source parameters, we are simply asked to assign the value from QSSTRESC to evalc. So we completed the majority of the derivations for source parameters. And now we are moving to the creation of that new derived parameter CHI, which is composite health index. So the first part involved giving a score based on the eval value for each parameter. So we'll now see how that is being done. So here we are checking, we are using our source 01 dataset, which had all the parameters. So as the input for this one. So before that, let's take a quick look at see source 01 dataset. and then see all the newly created parameters that were getting added. So in CHI01 we had information till TRT STT, then we created param CD, param, and param n. If you see, so the values from last character in param CD are extracted and converted into numeric, and then parcat1 is created, parcat1n is created, ADT is created, ADY is created, AVisitN and AVisit is created partially, but we'll be manipulating the values on the baseline records in next step. And then we also have our eval and evalc variables in this dataset. So we will now move to the next step, which is creating this new dataset called CHI01 using source01. So in this step, basically what we are doing is to assign the score for each of the parameters based on their responses. So we are checking whether eval is not is equal to missing as the first condition, and if it is param n1, so we were given the scores. So we could give the scores for each individual evals, like if eval is equal to 1, then score is equal to 0, else if eval is equal to 2, then score is equal to 0.05. So but here I am using a different programming logic instead of using if then else logic to create the score variables. So I'll quickly try to explain what it is, how it works. So here I am checking for the condition eval is equal to 1. So this expression would result in the value like 1 or 0. So on a particular record, the eval will be any of the possible values of 1, 2, 3, 4, and 5, but it will be only one of those values, not more than that. So if eval is 1 on a particular record, so what will happen? So this gets evaluated as 1 is equal to 1. So this condition will become true. So in what will happen in that case is, so the resulting value will be 1. So 1 multiplied by 0. So the entire value would get converted as 0. And then the second record. So if eval is equal to 2, because on the record which we are evaluating, we have said that the eval value is 1. So this expression was resulted in value of 1. So till here the expression resolved to 0. And here, so eval is equal to 1 is equal to 2. Is 1 equal to 2? No. So what will happen is this will get resolved to 0. So 0 multiplied by 0.051, which is 0. So far till here what will happen? So 0 plus 0. As eval is equal to 1, so when I am checking for eval is equal to 3 or eval is equal to 4 or eval is equal to 5, all these conditions would result in 0. So 0 multiplied by 0.063, and then here also as this expression will become 0, so it will become 0 here and all zeros. So the entire resulting value will become 0. So as the eval is 1 on that particular record, what is supposed to be the score? As per the specification, it was supposed to be 0. So this would become true. So let's now take a second case where eval is equal to 2. So here, what will this expression get resolved to? Is 2 is equal to 1? No, 0. The resulting expression would get resolved to 0. 0 multiplied by 0 is 0. And then we are adding plus is eval. So for us now eval is 2. So is 2 is equal to 2? Yes. So what will be the resulting expression value from this expression? So it will be 1. So 1 multiplied by 0.051. So far what will be the value of the resulting expression? It will be 0.051. So as eval is equal to 2 here, so 2 is equal to 3. So this will become false. So it will get evaluated to 0. And then 0 multiplied by 0.063 will be 0. Similarly for eval is equal to 4, this will get evaluated to 0. And then for 5 as well, this will get evaluated to 0. On any record, only one of these conditions will become true, and for that the resulting value would be multiplied with that 1 multiplied by that number. And then for all the other things, the expression of checking whether eval is equal to a particular number would get resolved to 0. So we will finally get a score which is required as per that eval. So in fact, if you wanted to, if you're not comfortable using this logic, you can simply write if eval is equal to 1, then score is equal to this. If eval is equal to 2, then score is equal to 0.05, and so on. For you will complete it for all all five results for that parameter. And then similarly, we are processing it for param n is equal to 2, param n is equal to 3, 4, and 5. So we'll quickly see how the scores variable will look like for NCHI01 dataset. So let's go to the right side. So here if you see, this is our parameter 1. So the response here is 3. So let's go back to the specification and see what was supposed to be the score for this. So let's go. So for the parameter 1, response 3. Parameter 1, response 3, the score has to be 0.063. So the entire expression actually got resolved to that 0.063. So even if you had used if then else, so you would end up having the same value, or if you use this complex looking expression, it will still be the same. So we have assigned the score for each of the parameters. But for us, as per the specification, in the next step, we have to transpose the score for each of the individual parameters such that we get it on the same record for a particular time point. So we will be doing that in the next step. We'll see. So we are doing that here in the next step. So we are using our CHI01 dataset, which had the scores available as input for proc transpose, and creating our CHI02 dataset. So here, as it was mentioned, that we need to create one record per subject per time point. So I am making use of all the variables that correspond to the subject level variables for study and the time point related variables. So I have kept some variables here which are either time point related variables or subject level variables here on the by statement, and then I am transposing only those records which have a parameter value of 1 to 5, and then I'm transposing the score variable by specifying it on the var statement. And for the newly created columns, I want to name the columns based on the values present in param cd variable. So if we take a look at CHI02, we'll get a better understanding of how that looks like. So here we have the records for 11th May assessment of subject 1001. So we will now have a record created, a variable created for the score associated with each of the response the subject has chosen for each of the questionnaire item. So for EQ5D-5L01, the score associated with the response chosen for that subject for that parameter is 0.063, 0.076, 0.190 for third parameter, and so on. So we have now fetched all the scores onto a single record per each time point assessment. So now in the next step, what we need to do is make use of the equation provided and check if all the 5 parameters have a score available. If that is the case, so we have to create the eval for it. So here I am making use of my CHI02, which has all these things, and then I'm checking if all 5 have a response. So what does nmiss function return? It returns the number of variables that are passed as arguments that have a missing value. So if all 5 are expected to have a value of all 5 variables are expected to have a value, so the returned value should be 0. So I'm checking using nmiss function how many number of missing values are there in this list of 5 variables. So if it is 0, which means only if all 5 variables have a non-missing value, then do. So eval is equal to round off. So 1 minus uh, this is 0.9675 multiplied by sum of the scores. So I'm making use of sum function to add the resulting values present in all these 5 variables, and then rounding it to 2 decimals. So 1 minus 0.9675 multiplied by sum of the scores in all for all each of the individual 5 items, and then rounding the result to the 3 decimal values. So this eval would be populated only for the cases where all 5 are available. So, and then we are on this now. What will happen is this set of records actually correspond to our CHI derived parameter. So I am assigning the param CD value of CHI, param N value of 7 as per the specification, and then param value of composite health index, as we were asked to set the param type value to derived on this newly created or newly derived parameter. So we have set this, and then as per the specification, it was not mentioned to create a VLC, but I don't know, maybe I can either update the specification or remove this program from the program. But I am converting eval to character version to populate a VLC on this derived parameter as well. And then I am combining my ADQS 01 to CHI03, which has my derived parameter records. So let's go to CHI03 first, and then we'll see the eval value for that. So we now have the eval for CHI available and the param and param CD variable and other variables required as per the specification for the newly derived parameter as well. And then we are combining our source parameters and derived parameters and calling that dataset as ADQS01. If we take a look at uh, source 01, so let's go and see how many records were there. So we had 20. And in our CHI03, now we have 4 records. So in ADQS01, it should be 20 plus 4. So overall 24 records. So these 4 records should be of what happened. So let me try to filter for param CD is equal to CHI and then see how many records are there for. I'm using param. So here we have all 4 records of that were coming here in ADQS01. So now let's move to the next step. So what are we doing here in the next step? So we are creating baseline flag and dependent variables. So we know that for baseline flag, we first need to identify the records that are eligible, and then we will have to identify the latest record within that eligible records and flag ABLFLY on that record. So subset the records with non-missing result which are on or before treatment start date. Create ABLFLY by assigning the value of y on the latest record identified. So here we are using ADQS01 as input and then base 01. We are creating a dataset called base 01. So, but in this, we are sorting the records based on use sub ID, param, ADT, visit num, and QS seek. So, and here we are filtering for only those records which are on or before treatment start date and the result is not missing. So if we have more than one record in base 01 for a subject and parameter, so we have ensured that the latest record comes at the end because we have sorted the records within a parameter in ascending ADT manner. So the latest record would come at the bottom. So if we now choose the last record within each parameter for subject, that record is actually the baseline record. So we also know that we were asked to use eval value on this record which is getting identified for base, but this is only on one record we are creating that. So we will be using this information and merge it back to all the records in the subsequent step to populate our base and base C. So we have base and then base C created here. So in the next step we'll be merging back our ABLFLY. So ABLFLY will be populated on a specific record. So we are trying to identify that specific record using the values present in the variables use sub ID, param, ADT, visit num, and QSSeek. And in this step of merge of base 02, so we are only keeping that along with the key variables, we are only keeping ABLFL but not base and base C. So because ABLFL is associated with a specific time point of that subject and parameter, but base and base C is only at U sub JD and param level. So if we have to merge base and base C, the merge key only has to be at subject and param level. We will not have that time point related variables. So now for ABLFL merge, so we are only merging, we are only keeping ABLFL and then uh, using the time point related variables and merging it back to our parent dataset ADQS01 and creating a dataset called ADQS02. Now let's take a quick look at base 01. So here we have out of all the 20 records, so there are 12 records which are getting qualified for uh, what do we call baseline period. And then out of these records, so one record could become baseline. So all 12 records are here, which means that there were no records for a subject and parameter which are in multiple numbers, which means a subject had only one assessment during pre-treatment on or before treatment start date. So we have created this base 2 dataset and it which had ABLFL base and base C. So we were using the information till ABLFL and populate it in our ADQS02 dataset. So let's now take a look at ADQS02 dataset. It should now have a BLFL added towards the end. So we now have it, and if we see, it is populated on Y on some of the records, which means that those are the baseline records. And now let's move on to the next step. So in this next step, as we now have pulled ABLFL into our ADQS02, we can complete the derivation, second component derivation for AVisited and AVisit. So if ABLFL is equal to Y, so we are assigning the value of 0 to AVisited and baseline to the variable AVisit. So this completed our derivation of ABLFL and also the second component of derivation of AVisited and AVisit as well. And then we will move on to the derivation of base change and percentage change variables. I don't think spec had the percentage change variable, only maybe this comment might have been carried forward from some other program, but we are only creating base and change variable here, base C and change. So here ADQS03, we are sorting based on subject and parameter. So we are using the same base 02 dataset because we know that the value present on the ABLFL record in base eval and uh, eval C are now becoming base and base C. So we have created those two variables here, but using them in the merge at subject and parameter level. So you shouldn't keep base and base C uh, when trying to merge for ABLFL, and at the same time when trying to merge for base and base C at subject and parameter level, you shouldn't keep ABLFL here. So if you keep ABLFL here, so on all the records of the subject and parameter, ABLFL would be Y. So which means so your derivation will go wrong because of your logic or programming error. So and then here in this case, so base and base C would be populated. Let's go and check our ADQS04 dataset to see how base and base C are populated. So here if we see, so let's try to see. So here this is for mobility. So let me filter only for subject 1001. Let me filter for EQ5D, the first parameter. So here if we see, the first record is becoming the baseline, which has a eval value of 3, and this has Y on this record. So what are we supposed to do? So we are supposed to use the value present here and populate it as based on all the records of that subject and parameter. So we had two records. So on both of the records, so we had to have the base value populated with this 3 value. Similarly, the value present here in eval C is 3 hyphen. I have moderate problems. So the same value is being picked up and populated on all the records of that subject and parameter. So now we have completed our derivation for base and base C. So next we will move on to the derivation of ANL01FL. So here what are we doing? So we are sorting our data based on. So no, in the next step, what we are doing here is completing the derivation for ANL02FL and change in ADQS05 dataset. So we are checking whether ADT is greater than TRT STT. So we were said that baseline records could be identified using ADT greater than TRT STT. So on all those records, so we are assigning the flag ANL02FL. And then for change variable also, we were specified that to populate change only on the post baseline records, which means on only on the records where ADT is greater than treatment start date. So we are within that condition, we are using another if then else statement to create our change variable. So for change variable to be calculated, both eval and base has to be not missing. So we are checking whether both of them have a value using this condition and then creating the change as eval and subtract base from it. And then this completes the derivation for ANL02FL and change. And then we'll move to ANL01FL. So the definition for ANL01FL is if there exists more than one record within a visit per subject and parameter. So we were asked to populate it the flag ANL01FL as Y on the latest available record. So we are sorting the records such that all records of a subject and within the subject all parameters come together, and within the parameter all visits records come together. And within a visit, if we have more than one record, so we are sorting it by descending ADT, which means the record with highest date value or the latest date value would appear first in that visit. So And then here in the next step, what we are doing here is we are populating this flag NL01 is equal to Y on the first record within that visit. So, but we have ensured that the first record corresponds to the latest date by sorting them in descending manner for ADT variable. And then we are also populating this ANL01FL only on those records where a visit n is not null, because we have not populated unscheduled a visit n on unscheduled records. So we do not need to flag ANL01FL. So we are checking for this additional condition as well. And then finally we are sorting the data based on use of JD, paramin, a visit n, and ADT. And then we had some additional variables which we were supposed to fetch from ADSL. So I'm doing a merge with ADSL again here towards the end. So if we go back and see in the initial merge of ADSL, as I mentioned earlier, so I'm fetching only TRT SDT because I needed this for intermediate processing of some additional variables. So I fetched only TRT SDT. So we can in fact fetch all the variables from ADSL at this step only, but it becomes a little tough to manage. So if you have more variables, specifically when you are trying to create some derived record. So here if we see, so if I had to keep all the variables from ADSL onto the derived parameters, I would have to list the entire list of variables here on the by statement based on the processing which I chose. So I avoided that, and I wanted to restrict the number of variables that appear here in all my intermediate datasets which are not required anywhere in the intermediate processing, and then finally merging it at the end again to fetch all the variables from ADSL. And then finally I am keeping a list of variables that only have to be kept and in the same order. So I have assigned the entire list of variables to a macro variable named var list and used it in two places. The first one on the retain statement and the second one on the var list. So when the variables appear in this order in the retain statement, so the final order of the variables that appear in the dataset will be in the same order. And then only as I'm making use of this list of variables in the keep statement, only this set of variables will be kept in the final data set, and any intermediate temporary variables that are getting created in somewhere in this process will be automatically dropped. So this is how we can complete the programming for ADQS dataset, so which is of a BDS, which shares the structure of BDS, so which is a basic data structure in short. Uh, so if you are following my other videos also, you might have noticed that the processing for ANL01FL, base C, eval, ABLFL, and other things remain constant in BDS structure. So at least within a study. So hope this is helpful. Thank you for watching and keep learning.